Hey there and welcome. You ever look at a huge list of numbers, test scores, sales figures, whatever, and your eyes just kind of glaze over? They're everywhere. Well, today, we're going to learn how to tame that chaos. We're building a simple toolkit to make sense of all that data using some basic statistics. So let's get into it. Okay, just look at this mess. Let's pretend these are test scores for a class. Right now, it's just a jumble. You can't tell just by looking if this class is doing great or really struggling. This is what raw data looks like. And believe it or not, there's a story hiding in there somewhere. Because there absolutely is a story. And our job right now is to be data detectives. We're going to use a few simple tools to figure it out. So the big question is, what are these numbers trying to tell us? Let's find out. All right, our first tool is all about finding the center of the action. We need to find one single number that can pretty much represent the entire group. This is the first and most important tool in our Data Tamers toolkit. And there's a name for this. It's called a representative value. So instead of getting lost in all those different scores, we find one number that gives us a quick snapshot of how the whole group is doing. Think of it like summarizing a whole movie in a single headline. So, how do we find this magic number? Well, we've got three main ways to do it. First up is the mean. That's just the good old average you learned in school. Add them all up, divide by how many there are. Then there's the median. That's the true middleman. You just line all the numbers up and pick the one smack dab in the center. And finally, you've got the mode, which is basically the most popular number, the one that shows up more than any other. Good question. So you might be thinking, what happens with the median if you have an even number of data points? If you have 10 scores, there isn't one single number in the middle. But don't worry, there's a really simple fix for that. It's super easy. First, you still line everything up from smallest to largest. Then you find the two numbers that are sharing that middle spot. And finally, you just find the average of those two numbers, and boom, that's your median. Simple as that. So, which one should you use, the mean or the median? This is a really important question. The mean is great, but it has one big weakness. One really, really high or low number, we call that an outlier, can totally throw it off. The median, though, it doesn't care about outliers. It gives you a much better feel for what's typical when your data is a little lopsided. Okay, finding a representative number is a great start, but it's just the headline. To really get the full story, we need to see the whole picture. So the next set of tools in our kit is all about organizing that jumble of numbers so we can start to see a pattern. And one of the quickest and maybe kind of weirdest sounding ways to do this is with something called a stem and leaf plot. Yeah, I know, it sounds a little strange, but it's an amazing way to sort your data and see how it's spread out all at the same time. So here's how it works. See the stem on the left? That's the tens digit. And each leaf on the right is the ones digit. So that top row with the stem 2 and leaves 4 and 6, that's the numbers 24 and 26. The next row, that's 31, 33, 35, and another 35. Just like that, we've sorted our numbers and we can instantly see that most of them are in the 30s. We even found the mode. See how 35 shows up twice? Now, for a more traditional approach, we can use a frequency distribution table. This is a bit more structured. All we do is create some buckets or classes, like scores from 60 to 70. Then we just go through and count how many numbers fall into each bucket. This little act of grouping and counting is actually the first step to creating really powerful pictures of our data. All right, our data is organized, it's all neat and tidy. And now it's time for the really fun part. We're going to turn these boring tables of numbers into pictures that tell the story in a single glance. So here's that frequency distribution table we were just talking about, but using our original test scores. We've got our score ranges and we tallied up how many students fell into each one. So you can see 4 students scored in the 80s, 2 were in the 70s, and so on. This is organized for sure, but the real magic happens when we visualize it. And bam, we turn that table into what's called a histogram. Each bar is one of the score ranges from our table, and the height of the bar tells you how many students are in it. Now, you don't just see the numbers, you can feel the shape of the data. That big spike in the 80 to 90 range just jumps right out at you. That's the story of the data in picture form. Now, a close cousin of the histogram is the frequency polygon. Instead of bars, it's a line graph that just connects the dots at the top of where the bars would be. Now, a histogram is amazing for looking at one set of data, but the real superpower of the polygon is that you can put 2 or 3 or more on the same chart to easily compare them. And that brings us to our final challenge, and it's a really common one. How do you actually make a fair comparison between two groups when they're different sizes? I mean, is having 7 students out of 50 pass a test better than 3 out of 20? This is where our last tool is absolutely essential. The secret is to stop thinking in raw numbers and start thinking in proportions. And we do that with something called relative frequency. It's so simple. You just take the number of items in a category and divide it by the total number of items. This turns everything into a nice, clean proportion or a percentage so you can make a true apples-to-apples comparison. Okay, let's look at this exact problem. In Class A, you've got 3 students who got top scores out of a small class of 20. In Class B, 7 students got top scores, but it was a much bigger class of 50. Now, at first glance, 7 feels better than 3, right? But is that the whole story? Let's use our new tool. For Class A, we're going to divide those 3 top-scoring students by the 20 total students in the class. That gives us a relative frequency of 0.15. Or to put it another way, 15% of the class got a top score. Okay, now let's check Class B. Now for Class B, we take the 7 students and divide by the 50 total, and we get, 0.14. That's 14%. And there is our answer. It was so close, but Class A, the one with fewer top scores, actually performed slightly better as a proportion of the class. Relative frequency gave us the true story. And there you have it. That's your starter toolkit for taming any data that comes your way. You now know how to find the center, how to organize the chaos, how to draw the story, and how to make truly fair comparisons. These are powerful tools to have. So now you're equipped to look at all the numbers around you, in the news, at your job, everywhere, and you can start to ask the right questions. You have the tools to dig beneath the surface and find out what's really going on. So the only question left is, what story will you uncover first?